Hi everyone, my name is David Ford with Edge Engineering and Science, and I'm going to talk to you today about a rare East Texas mussel called the Louisiana Pigtoe and some of our life history work on it. So Texas was a little late getting into the musseling game. There were some initial surveys done in the 1970s and 80s, but it really wasn't until the 1990s that survey efforts really kind of got kickstarted in the state. And then in the early thousands and the mid thousands, there was kind of this renaissance that caused an explosion of mussel surveys across the state. And since that time, we've really gotten a pretty decent idea as to what we've got and where it's at. So the information that's lacking now is more life history stuff. So like host fish, when they release their glaucidia, reproductive timing, things like that, plus just genetic verification of our species. So currently Texas is looking at having around 50 or so species, depending on which geneticist you're talking to that day, as it seems that they change it almost every day anymore. And this includes several endemic and rare species. And like most of the species across the US, they're experiencing some pretty significant declines, such that in 2010, Texas Parks and Wildlife listed 15 species as threatened at the state level. And since then, several of those species have been petitioned for US Fish and Wildlife protections. So this slide shows the initial 15 species that were listed by parks in 2010. And since that time, several things have changed. Several species have been lumped together, several species have been reclassified, and some species have even been removed as species altogether. So now here in 2021, Texas currently has 16 species listed as threatened at the state level. This includes several new species like chuni and neki. There have been several species that have been removed like aria. One has been officially listed by the feds. Papia down in the corner. There have been several reclassifications, and lots of these species are still being reviewed by the feds to determine if they warrant any protections. This includes several listed species that are in East Texas, which is the portion of Texas I'm going to be talking about today. These species include Lampsilla satura, Fuscinae ascui, Petamelus amphicinus, Obovaria arkansaensis, and the guy that I'm going to be talking about today, the Louisiana Pigtoe Pleurobema riddellii. So historically, Louisiana Pigtoe was found in Oklahoma, Arkansas, Texas, and Louisiana, although there is some genetic work currently going on to verify that it's the same species in all of those different states. Here in Texas, the species was found only in East Texas, so basically from the Trinity to the border with Louisiana. And it's had some pretty significant declines, like a lot of the species in Texas have, such that the only places you can really still find it are within the Neches and the Sabine rivers. And really, in any kind of numbers, you can only find it within the Neches anymore. And that's one of the reasons that we've done a lot of our work there, just because this species is there. And there's still a lot not known about this species. There's a lot of life history information that's lacking. Currently, we know some information about its fish hosts, and we know some about its growth rates, but that's really about it. There's still quite a bit of information that we don't know yet. So the Neches River Basin is one of the most pristine basins left in Texas, if not the most pristine, although I will admit I am slightly biased as it is one of my all-time favorite places to be. It drains an area of about 26,000 square kilometers, and it's got a couple of large tributaries on it, like the Angelina River and the Atoyac Bayou. And one of the reasons that it's as pristine as it is because it lacks any major reservoirs. Really, it's got a couple, like it's got Sam Rayburn and B.A. Steinhagen, but that's really about it. So it's pretty pristine compared to a lot of our rivers here in the state. And that's one of the reasons it's been the focus of a lot of our research and a lot of other people's research as well. Another cool thing about the Neches is that it's got a very, very diverse mussel community. There's over 30 species that can be found within its waters, and this includes multiple listed species, including several relatively large, you got to throw that caveat in there for a listed species, relatively large populations of riddellii. So here are a couple of pretty pictures of the Neches just to give everyone kind of an idea of what the basin looks like. You can kind of see there's some woody debris. It's just a very fun place to be, some waterfalls and all that. And it's got everyone's favorite thing to dive with in there too, alligators. So for our current study, we picked 3 locations in the Neches based off of basically a decade's worth of research in our ecological niche predictive modeling that we've done, and picked the 3 locations that we found that had the highest density of riddellii. So these were the best sites out of all of our research that we could find. And this includes a site near Highway 294, one near Highway 79, and another near Cherokee Hunting Club Road. At each of those locations, we measured out a 150-meter stretch and broke that up into three 50-meter stretches. Within each of those 50-meter stretches, we surveyed 27 randomly placed quarter-meter quadrats. At whichever quarter-meter quadrat had the highest density of riddellii, that's where we placed our mark-recapture grid that we used for this study. So we literally took the best sites that we had and found the best locations within those particular sites. So once we had found that one particular quadrat and made our 5 by 5 meter grid, we excavated the entire grid for riddellii, and we ended up every riddellii that we recovered, we measured, aged, and gave a pit tag and a B tag to. So we went back each year between 2014 and 2019 and excavated our 5 by 5 meter grid again. We did this at about the same time each year and used the same crew lead to ensure that we had consistency between study years. Any new riddellii that were collected were given a pit tag and a B tag, were measured and aged, and then any previously collected riddellii were just measured and aged and their current status was recorded, whether they were alive or dead. We've used all this information then to calculate several different variables. This included recapture rate, and then we also used it to create a mark recapture model. So we fed all of this information into the program Mark, used it to create a ProPan model, which then gave us several life history variables for this species, which included parent survival, the recapture probability, the probability of a new mussel coming into the area, and then the population size of that whole grid that we had. And we used ACCI's information criterion to ensure that our model was the most parsimonious, so it was the best fit for what we were trying to do. And then we compared this information between all three of our sites to see if there were any differences between them. So this slide shows our densities that were recovered during the different parts of the study. The main thing to focus on here is the difference between the initial density from those 27 quarter-meter quadrats and then our densities in the 2014 grade and the 2019 grade. Specifically, look at the Highway 79 site. Had we just focused on that initial 27 quadrat density, we would have basically thought that there weren't any riddellii at this site. But then if you look at the 2014 one, we've actually got almost 1.5 per meter squared. And then by 2019, we've got 3.2 per meter squared. That's actually a pretty decent population. And had we just focused on that initial density, we would have missed this entire group of animals. The other thing to kind of note here is the same thing's true with the Highway 294 site, right? So the initial density in those quadrats was only 0.2. By 2014, when we did the actual grid, it was 2.6 per meter squared. And by 2019, it was 9 animals per meter squared. That's a massive density for a rare animal. And we would have missed this really healthy population had we just focused on those initial quadrats. The other thing I want to mention here is the reason that the density is so high at that Highway 294 site is because that is a really healthy reproducing population. So there were new individuals coming into that population as they were getting big enough for us to actually find and put pit tags on and everything. So it was a growing population, whereas the other two were kind of static and stable. So these figures show our recapture rates that we got for riddellii throughout the study, and we had pretty good recapture rates. We ended up with about 55% over the entire study, and you can see that essentially by about 2017, we found almost everything. There is a little bit of a jump by 2019, but that's mostly just due to a flood that occurred in 2017. And there were no differences between the three sites as far as recaptures go. This slide is a little busy, but it shows the three models that we ended up with for each of the sites along with our overall model. The main one to focus on for this is the parent survival, and I want to point out that survival for all three of our sites was over 80%, which is really good. You want a really nice high survival rate for a rare species like this, although I will say that it's a little lower than what's typically found for mussel studies like this. As we all know, once mussels are adults, they tend to be okay unless something significant happens like a dewatering or something. Also, the three variables, apparent survival, the recapture probability, and the probability of a new entry were not significantly different between the three sites, so they were basically the same. What was different, though, was the population size between the three sites, specifically between the Highway 294 site, the CHC site, and the Highway 79 site. And that's, again, because that's that nice reproducing population, and it's growing. The other thing I want to point out here is that if you take the predicted population size versus what we actually recovered from each site, we actually ended up with over 90% of the mussels that were predicted recovered from each site. So we got really good coverage from each site. especially at the Highway 79 site where we got almost 100% of mussels recovered. So in conclusion, we've provided some of the first vital rates for a rare unionid out of Texas, and some of the first for a species out of Texas, and the first for riddellii other than growth rates, which we've reported earlier. And we've gotten some pretty high survival rates and some recovery rates for this species. Not quite as high as what would normally be expected, but still very good for a rare species. And the other thing I just want to drive home again is the differences between those initial quadrats and the actual grids. And just really point out that had we focused on that initial survey effort, we would have missed two really good populations, right? That Highway 294 one we might not have thought was as good as it was. That Highway 79 one we might have missed altogether. And it really, really just drives home that you've got to put in enough time to be able to find rare species like this. And that Highway 294 site is a really good site. It's got really high density, it's clearly reproducing, and it's very much worth protecting. And it brings up this whole idea of making tailored conservation plans, right? Like if we could say put more money to protecting the Highway 294 site versus the Highway 79 site, then we might get more money for our conservation buck and be able to stretch it even farther and hopefully make a better plan to conserve a species that's rare like this. Here we presented some new information on a rare Texas unionid that's currently under review by U.S. Fish and Wildlife for potential protections. And we've shown that the upper Neches is very much worth protecting. It's one of the few places that the species still exists in any kind of numbers. And we've shown that there's still some pretty decent densities of this species up in the basin. I do want to caution though that these densities are likely not the same densities that would be found anywhere else. Remember, we went to the best of the best sites. So the densities that we found are probably more reminiscent of historical sites versus what would be found if you went looking in other basins or elsewhere in the Neches for this species. So with that, I would like to thank our funding sources and the different students who have worked on this project over the years, and I would be happy to answer any questions.